Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocket Man, and today we are talking about the JAXA Slim. Hey Ben, how are you?
Hey Simon, how's it going? Hey fellow Econauts. Yeah, today we are talking about JAXA's ambitions to land on the moon with a small lander. It also has the nickname the Moon Sniper.
The Moon Sniper. That's interesting. Well, that's already leading us to our first question. What is actually Slim?
Slim, well, I'm slim and you're slim. No, I mean,
Not
joke
that slim
aside,
anymore.
not anymore. I have to get slim. Now, slim is an abbreviation and it stands for Smart Lander for Investigating Moon. And it's the mission from JAXA, as I just explained, to land a small and light vehicle very precisely on the lunar surface.
Already leads into the next question. What is actually the purpose of Slim?
Well, the overarching purpose, as usual, when currently space agencies are looking into getting to the moon, is finding water. Finding water on the moon is sort of our priority number one. And in order to do so, we need to be able to go more often and rapidly. We have talked about this with the Gateway mission and also the permanent base on the moon. Obviously, they need water in the first place, but also that will open up a possible lunar economy at some point because we can get there more rapidly and more and cheaper, and more or less the same aligns with the JAXA Slim mission. They are now looking to build a very light vehicle which can go there with its own propulsion. That's why it takes very long to get there for them, and at the same time they want to test a couple of new technologies to land very precisely at locations they think are interesting, so that they actually don't have to rove. That's sort of moving a rover over long distances. So they land very close where they want to investigate something, and that's they want to do a pinhole descent onto that location.
Maybe we can go a little bit more in detail. What is the specialty of Slim?
Yeah, so you can imagine landing on the moon comes with its own problems and challenges. One of it is obviously we don't have GPS on the moon, so having actually your location is quite hard with, just knowing where exactly you are, how high above the lunar surface you are, and so on. And also, if you then want to land on a very precise location, same thing. How do you do this without GPS? So what they do is they actually fly and orbit the moon, fly to the moon and orbit the moon for a while they have a camera looking at the surface, and that camera is used to identify craters, which they can use to sort of map and locate where they are. The other big challenge landing on the moon is that we have no atmosphere, so there's no deceleration of the atmosphere when you go down. So you have to have very precise thrusters so that you can maneuver your vehicle, your lander, very precisely without crashing. And then the last thing is remote operation is next to impossible, because with a 15 seconds delay minimum, because of the distance and network hopping and so on, you can't, if you in the moment you land, we need to turn a little bit 69 degrees rotating clockwise, and then you do this 15 seconds later, that thing is already smashed into the surface. So there's a couple of challenges, and the significant technologies are machine vision and a light vehicle, so that they can actually, it's not super expensive. Obviously the first one is, but it demonstrates that you can build it lightweight and less expensive.
That also means that there is a certain AI already integrated in the system, right?
Yes, and that AI has to manage to not only orient and navigate, it also in the descent phase. So the way, maybe you can show a picture in the edit. The way it lands is that that Slim goes more or less vertically down with its thrusters and everything, and in the moment it tips down, it has to tip forward to fall on its base, more or less. because that's how it works. And then all the solar panels are on the backside.
I looked at the equipment specifications and I was very impressed about all the systems that are actually implemented, like the shock absorbing system and the payload mission system. Maybe you have some ideas what they are.
Well, I think every detail of a space mission comes with a lot of engineering and design. We could take any of those subsystems and they will have years of design and development in that. Just to give you a bit of an appreciation how old this project is. It is actually has been initiated already 2002, derived from another mission, but in its current form has been proposed 2012. And since then, JAXA has worked on this mission, and we have obviously now 12 years later. So you can see how much time goes into this. So from actually developing the thrusters, the tank where everything like the fuel is stored in, the landing radar, the camera system itself, the integrated computer. The integrated computer maybe is also interesting to mention. On Earth, we have high power computer. They can do machine vision quite easily these days. You don't have that budget that it's called the power budget available in space. For an FPGA, that's a small computer on such a vehicle that doesn't have so much RAM and so much CPU power as we have here. So you have to slim down. And pardon the pun, you have to slim down.
That's
the whole hardware architecture, the whole software architecture has to be very, very lean in order to fit on a light lander and still be able to work with a budget. And then just to give you an appreciation of the landing sequence, in order to land, Slim will go down vertically, and in the moment it touches down, it has to fall forward to be in a position how it's supposed to be. And also the other challenge, because they use their own light propulsion system, the transit between Earth and Moon was about 3 to 4 months, and then orbiting the Moon was another month. So it takes a lot of time to actually get there compared to SLS, where it took mere days to surround the Moon and come back. So obviously, this comes all with challenges, and you need to be able to correct a little bit your trajectory and so on. So I think any of those points. Maybe one thing we could quickly talk about is what are the mission success criteria. So at minimum, they want to conduct a test that they can land on the Moon, only based on the vision navigation they have. And that this, because that's essential for showing that they can do high precision landing. And also the second minimum success criteria is to show that this spacecraft is able to do that, because then they have shown that a lightweight spacecraft can operate for these conditions. To achieve the whole criteria is they want to land within 100 meters of their location where they want to land. They land close to the Lake of Nectar, I think that's what it's called. And and they want to obviously only use the navigation system they have on board for that. So if they have that, then they have more or less been successful. Obviously, they have already put some scientific equipment on board to get some probes down and so on, and that's an extra. If they achieve using those type of equipments, then they have done a wonderful job.
Right, and I think the next step would be to upscale, right? So to have like more of those mini landers on the Moon to increase the likelihood of finding water on the Moon, because like you already mentioned, having water on the Moon, it's allowing us not only to make oxygen, but also to make fuel again, right? With hydrogen, if I'm not mistaken, which is like the propulsion system for rockets.
Yeah. Also, although it's on Earth, it's not a good idea to use hydrogen as a energy storage. On the moon, it might be our only way to do so. Because then you only have to build big tanks, and over the lunar day, which is 14 days long, you can collect energy via solar energy. And transfer water to hydrogen and oxygen, which you have to do anyway. And the hydrogen can then be used also to generate electricity with a fuel cell. So you could, and that is important for the 14 days of lunar night you have, where you don't have solar solar energy available.
Yeah,
right.
Absolutely.
So that's definitely a very good use case there. And one thing you mentioned is, like just having the ability is not only for the moon. This type of landing system can then also be used for asteroids and other celestial bodies without atmosphere. So that is a big win. And one thing we have mentioned in the past as well, imagine you would send a probe to Earth, one probe, and that probe lands into the ocean, and you send now all the data you get from the ocean, you send back to your home planet. Now you think on your home planet, Earth is just a ball of water. Right,
exactly.
So we don't know anything about that. So only sending one probe is not enough to get a good idea what the moon is made of. I mean, we know what the moon is made of, more or less, but we haven't unlocked all the secrets of the moon. We had like 14 samples from very close locations on the moon. It doesn't tell us anything really. So we extrapolate a lot, and I think it's safe to say that the more rapidly we can go there and take samples, the better we will understand the history of our moon.
Yeah, I see that too. I mean, it's a very, very important step to establish a radius of scanning the moon and to get more information of what the moon is made of. And you made it very clear, if we have only one probe putting into the ocean and we would be aliens, we would only think like it's like water, right? But it's also, if we look in our own history as humans, I mean, the Roman Empire thought that they conquered the world, but in fact they only conquered Europe, right? If you really think about it. And if you would take a plane and you would go to the different countries, you would not only experience different climates, but also different food and different cultures and so on and so forth, right? So, and we have the ability to do so more closely because of the internet and because we are more connected to each other. And that is something that is, of course, missing on the moon. That's something that we have established, that we need to establish on the moon. And I think what JAXA is doing with the SLIM mission, it's one huge step into achieving that, right? To actually have like the data available that are necessary to see where to build a base, where's the best location, because what we also don't want is having like a huge pipeline from one side of the moon to the other side, just to
through it,
just to get like water from one side to the other side, right?
Yeah. No, absolutely. And look, if you have a mining exploration going on, they have drilling programs, and they don't drill randomly. They maybe the first one is like, maybe there's something. They take usually rock chip samples, and then they sort of have a guess where they should drill. But once they start drilling and get the samples out of the ground, they get a better idea where to drill next. And these kind of strategies are only possible if you have more than one drill.
Exactly.
Right? So if you only send one drill, okay, which direction do we go next? So, we don't have wind on the moon. We can't even do that.
Let's flip a coin. Which also would flip like forever, right? Okay, let's end it for today. That was like super interesting. I would like to say thank you for watching, and I hope you had a good time. If you did, please don't forget to leave a like, subscribe if you haven't already,
and hit that notification bell to get slim.
Exactly. And stay slim. All right. Okay, have a good one. Bye-bye.
Bye.